Good evening, everyone. Welcome to Byju's Exam Prep IAS. Today, in this session, we are going to have a discussion on the important topics related to science and technology from the month of June 2024. But before we begin, uh, just a reminder, if video and audio both are working fine, please let me know. Please give me a thumbs up. All good? Wonderful. Great. So let's begin with the session. Now, in today's session, we have topics from all across. We have topics related to space technology, we have topics related to biotechnology, biology, defense, intellectual property rights. So there are multiple different facets of topics that we have for today's session. So these are the list of topics. I know the number of topics that we are taking today is a little on the higher side, but I saw all these topics which look to be very important, so that's why I am covering all these topics. So these are the topics that we are going to cover. So these 12 plus these 7, so total of 19 topics that we are going to discuss in today's lecture. Some of these topics are pretty small topics which are largely related to your prelims examination, but there are certain topics which need a deeper analysis, which might also be important for your mains examination. So let's begin. The sources that we have taken, there are 5 basic sources which we have taken for today's session. uh, the Hindu, the Indian Express, Science Reporter, Press Information Bureau, and the DRDO newsletter. So these are the 5 different sources from where I have picked most of these topics in today's lecture. So what we'll do is we'll go topic by topic. We'll start with space technology as our first segment. And as you know, always is the case in your newspapers or whatever be your current affairs source, space technology will always have the most number of topics, and that's the case here also. So let's start with the first topic. ISRO develops Pravah software for aerodynamics design and analysis. Now, what we have seen is that ISRO has developed a new computational fluid dynamics software which has been named as Prahas. Pravah. Now, when it comes to this particular software, that is Pravah, this has been developed at ISRO's Vikram Sarabhai Space Center. Now, Vikram Sarabhai Space Center is where everything with regard to the design and development of the launch vehicles is done at ISRO. So, when it comes to it, just remember that it has been developed at Vikram Sarabhai Space Center. Now, when it comes to this particular software, sorry, when it comes to this particular software, this is a software which has been designed to simulate both external and internal flows on the launch vehicles, including both the winged and the non-winged re-entry vehicles. So it is going to simulate external and internal flows on the launch vehicles, including the winged and the non-winged re-entry vehicles. Now, what do I mean when I say something like that? Flows. What kind of flow? Any kind of fluid flow or any kind of air flow. So, for example, there are mechanisms working outside the launch vehicle, and there are mechanisms working inside the launch vehicle. There are fluids outside, for example, air that is there outside, and then there are fluids like fuel, etc., which are there, or even oxidizers, for example, which are inside. So that's why any kind of flow that's related to the launch vehicles will be taken care of. This is where we basically will try to simulate the flows both for the winged and the non-winged re-entry vehicles, meaning the ones which look like a missile, like a rocket, which do not have wings, and the others which have wings. For example, the airplanes, how the airplanes have wings. So both the kind of re-entry vehicles will be simulated. Now, when it comes to the key points, we have to understand some of the important parts regarding to this particular software. This is something that can simulate the airflow around the various kinds of aerospace vehicles during their movement throughout the Earth's atmosphere, or either during the launch or during the re-entry, meaning that either whether they are going upward or they are coming downward. In both the cases, it can simulate the movements. And that's why it will try to evaluate the external pressure and the heat to also try to understand the severe aerodynamic and the aerothermal loads that these kind of vehicles always endure. Sorry. So that's why you have to understand that these are some of the important points with regard to the capacity of this particular software. So what it is going to do is it is going to try and evaluate the external pressure and heat flux. External pressure and the heat flux on the launch vehicles. So whether any kind of aerodynamic and aerothermal load that these kind of vehicles endure during their flight, all those things will be understood better. It will be evaluated better. So that's why we'll try to understand. We will try to understand the severe aerodynamic, right? The severe aerodynamic and aerothermal aerothermal loads that these kind of vehicles would endure. So that's why when we look at the applications, the software basically has been extensively used in the Gaganyaan program for the aerodynamic analysis of the human rated launch vehicles. So for example, the ones that will be used in launching the humans, like the crew escape system or the crew module, in all these cases. So that's why extensively used in the Gaganyaan program, where we'll see that in the launch vehicle, the escape system, and the module that is going to carry the crew. All these will be, all these applications, all these areas will be simulated. And it can simulate the airflow for both the perfect gas and the real gas conditions. So that's why what we see is that the validations are ongoing for its use in simulating the chemical reactions which actually happen during the air dissociation and combustion processes. So especially when it comes to which are pertinent to the earth re-entry and the scramjet kind of vehicles. So that's why it will be very, very crucial, because we see that it will be able to simulate the airflow for both perfect and the real gas conditions. So overall, that's why we understand that there are a lot of advantages that we will get from here. So for example, Pravah is going to, or it is expected to also replace most of the commercial CDF or the CFD softwares which are currently used for the characterization in the aerospace design. And that's why it will also aid the academia and the other institutions which are also involved in the design of aircrafts or missiles or even rockets, by trying to provide solutions to all the complex aerodynamic problems that we actually see. So that's why expected to replace most of the commercial CFD software and provides academia and institutions in designing missiles, aircrafts, and rockets. And when we look at the technical aspects, we do understand that it is going to address the unsteady aerodynamics, which basically we are trying to address the unsteady part of the aerodynamics, which contributes to the flow issues and significant acoustic noise also during all these missions. And that's why these kind of tools like Pravah actually solve the equations of the conservation of mass, momentum, and energy, along with the equations of state to try to predict the aerodynamic and the aerothermal loads. So that's why when we look at the future prospects of a software like this, it is a software that holds the potential to become a primary tool for these kind of simulations in the aerospace design. And that's why it might be able to enhance the capabilities of ISRO and also support the academic and the research institutions in solving advanced aerodynamic challenges that they very often face. So that's why just remember this particular scenario or this software and what exactly this software does. Moving on, we are talking about one of the most important missions of this year, and this is the Chang'e 6 mission of China. So, what is Chang'e 6 mission and what is its role in China's moon missions? Now, before we go on to understand what is Chang'e 6 mission, let's first start with the history of all these missions. China's moon missions started with Chang'e 1, which was back in 2007. And this is where we see that it was the first Chinese spacecraft to travel beyond the Earth's orbit. Now, it is for the first time you can say that China had taken some kind of initiative towards the moon, where they were now going to focus a lot more on the lunar missions. So, the goal of the mission, for example, was stereoscopic imaging, surface chemistry analysis, and technology testing for future lunar or moon-based missions. So it for the first time, it for China, it created a three-dimensional map of the lunar surface and identified key minerals and the regolith thickness. Regolith, in a manner you can say, is soil. So thickness of the soil which is present in or on the surface of moon. So this was the first mission that they started with. This was the Chang'e 1 mission. And then after that, in 2010, they started, or they had the Chang'e 2 mission. Now, in case of Chang'e 2 mission, what we see is that the objective, in a manner, it was a follow-up mission to enhance the lunar imaging and support future landings for China. And then after that, what we see with regard to the goals of the mission is that this time they got a better resolution or a high resolution imaging and a kind of reconnaissance of landing sites for the upcoming mission, that was Chang'e 3. And that's why, as an achievement, you can say that it entered the lunar orbit quickly and provided a detailed image which would be used for planning of Chang'e 3's landing. Now, this is where we see that they go on for a more sophisticated mission, that was Chang'e 3. Now, this is where we see that this was the first Chinese mission to achieve a soft landing on the moon and deploy a rover. Now, when we say soft landing, understand the meaning of soft landing. Soft landing is where you are not crashing on the surface of a celestial body. So, the other term is hard landing. Hard landing, or what we also call as crash landing. So in this case, what happens is that you are just going to land. You do not want to control that landing. All right. So that will be called as hard landing. Now, for example, with Chandrayaan 3, also we have soft landed on moon. All right. With Chandrayaan 2, unfortunately, we hard landed on the moon, although we wanted a soft landing. All right. So with Chang'e 3, they achieved a soft landing on moon, and they also deployed a rover. What is a rover? Even we launched a rover with Chandrayaan 3. What is a rover? Something that will move around. Anything that goes to that surface and moves around, this will be called as a rover. So here, for the first time, they conducted on-site analysis of the lunar surface. That was the key objective. This was the mission goal. And the achievement, you can say that for the first time, they landed. All right, they landed on the moon. They deployed their rover, which is called as U2. And then they conducted significant scientific experiments on lunar soil. And at the same time, they experimented on lunar geography as well. So this is basically what we see with the Chandrayaan 3 mission. And then 2018 is when they had their Chang'e 4 mission. So this Chang'e 4 mission, this was the first mission to land on the far side of the moon. Now this is very, very crucial, that this was the first mission to be launched at the far side of the moon. Also remember this fact from the perspective of your prelims examination. For example, what UPSC can do is that they can give you a statement, and the statement might say that Chang'e 6 mission is the first mission to land on the far side of the moon. That will be a wrong statement, because they have already done that with Chang'e 4 mission. So this was to explore far side of the moon and conduct astronomical observations free from Earth's interference. Now, why are we saying that this would be something which is free from interference from the Earth? Understand that. And we'll discuss that when we talk about far side of the moon. So that's why achievement wise, you can say that this is where they successfully landed on one uh, Karman crater, and they deployed another rover, that was U-22, and this is a rover which is still operational, and they have been providing valuable data about the lunar far side geology. Now, after this, and we'll discuss about Farsight. Just give me some moments. I'll discuss about Farsight as well. Coming to Chang'e 5 mission, which was taken in 2020. This is where their objective was that this was the first Chinese mission to return lunar samples to the Earth. All right. So the goal was to collect and return samples from moons. Just remember this, moon's near side. All right. So they went to the moon's near side and they collected and returned samples from moon's near side. So that's why achievement wise, you can say that this was they were able to return 1.73 kg of lunar samples from uh, the Oceanus Procellanar Random region. And then this was first such mission since 1976. And it also showcased, it demonstrated China's ability also to perform these kind of complex robotic operations, including collection of samples or ascending, docking, all these kind of things could be done. And China showed that they have the capability to do all that. So this, you can say, in a manner, is the history of these kind of missions. Now, when it comes to the new mission, that is Chang'e 6 mission, which is in the news, what we have seen is that this mission aims to replicate what Chang'e 5 mission had done, but this time not from the near side, but from the far side. So you can say that after Chang'e 4, this is the second time when China is going to the far side of the moon. Last time they just went to this far side of the moon, and they tried to understand and conduct certain experiments on the far side. This time what are they doing? This time they have gone to the far side, collected samples from there, and they have brought it back to the Earth. So this is basically what they have done this time, that they have replicated Chang'e 5's success, but this time from moon's far side. So you can say that this is for the second time that China has gone to the far side of the moon. Last time they just went there, observed it. This time they've gone there, collected samples, and they've come back. So that is what Chang'e 6 mission is. So it aims to understand the differences between the moon's near and the far sides. All right. Now, because I'm saying so much of what near and far sides are, let's try to understand what do we even mean by near side and far side. As you can see that there are these two sides of moon. One is called as the near side of the moon. The second is called as the far side of the moon. Now, what exactly do we mean by near and far side? Now, what we say is that moon is tidally locked to the earth, meaning that the same hemisphere always faces the earth while the other always faces away. Understand this. All right. So when you look at the moon, what happens is that as moon revolves around the earth, what we see is always the same face. So what we see always is only this side of the moon. What we see is only this side of the moon. We never see the other side of the moon. We never see this side of the moon. This side of the moon that we never see from the earth is called as the far side. All right. The side of the moon that we never see from the earth is called as the far side, and the one that always faces towards the earth is called as the near side. All right. So this is what we mean by near and far side. And it's not that from India you are looking at the near side, and for the US or the other side of the globe, near side is different. No, near side is near side for across the earth. whether you are looking at it from India or Pakistan or Europe or from US or from Australia, wherever you are looking from, you only see the near side of the moon. All right, we see only one side of the moon. And the reason why this happens is, we say that the reason is something called as tidal locking. So what we know is that moon is tidally locked to the earth, meaning that only one hemisphere always faces the earth. Tidal locking is where only one hemisphere always faces the earth. All right, only one hemisphere always faces the earth. Now, when it comes to the difference between the near and the far side actually is said to be much rockier, with fewer smooth plains, and likely due to the differences that we see in their geology and geography. As you see, that near side is where you see a lot of surfaces which are much more even, whereas when it comes to the far side is far more rockier with very fewer smooth plains, and this is likely due to the differences in the heat and the surface characteristics from the moon's formation. So that's why landing on the far side of the moon is much more challenging due to the lack of direct communication with the earth. Understand this, we are only looking at the near side of the earth, or sorry, of the moon always. We never see the far side of the moon. The moon, I mean, if this side of the moon is facing you, this is the near side. We never see the far side. And for the communication to be established, any satellite you are sending, it should be able to directly communicate with the earth. Suppose that the satellite is here, right? If the satellite is here, how would that satellite be able to communicate with you, right? It wouldn't be able to, correct? So because it is on the other side of the moon, so it can't communicate unless it is here, right? So that's why landing on the far side of the moon is way more challenging, because there is a lack of direct communication with the earth. All right, so I'm writing it out here. Landing on far side is way more complex due to lack of direct communication. All right, so this is basically what we see. Now, how do we solve this problem? We use a relay satellite. All right, how do we solve a problem? For solving this problem, we would need a relay satellite. So a relay satellite is needed to transmit the signals, and this adds to the complexity of the motion of the mission like this. So the far side is also believed to, just remember this, that far side of the moon is also believed to have more of some of the other minerals or other elements like helium 3, which is potentially a fusion reactor fuel, and it is considered to be an ideal location for very large telescopes also to be set up. Why far side? Because far side is completely away from the earth, uh, no kind of interference from the earth, so we know that we will be able to carry out missions or carry out observations better. So in the future we might even want to place a telescope on the far side of the moon. All right, so just remember this. So relay satellite, that's why we would make the use of relay satellite, so that one satellite communicates with another, and that other satellite will be sending the information to the earth. So this is what we see. Now, when we say that only one side is always visible, only one side always faces the earth, why does this happen? This happens when the rotation and revolution periods are the same for moon. All right. The rotation and the revolution periods are the same for the moon. So, for example, let's say when you consider the Earth, we know that the rotation of the Earth finishes approximately in 24 hours. The revolution takes up to 365 days, correct? So, there is a huge gap between the period of rotation versus period of revolution. But that's not the case with Moon. With Moon, what we see is that for Moon, the rotation and the revolution periods both are approximately the same, which is approximately 27-28 days. All right. Now, why does it not happen for the Earth? The answer is it will happen for the Earth also. So what will happen for the Earth also is that our rotation periods will keep slowing down and our revolution periods will keep speeding up, and there will be a time when both rotation and the revolution periods of the Earth also would become equal, and then Earth might become tidally locked to the sun, meaning that only one part of the Earth always will face the sun and other part will be completely dark. But will this ever happen for the Earth? The answer is no. Why no? Because it's not because the Earth is not capable. It can happen for the Earth also. But before something like this happens, the amount of time that something like this is going to take, before that, even the sun is going to be destroyed. It's going to take millions and millions, sorry, billions of years. And before this tidal locking happens for the Earth, the sun would be destroyed before that itself. So that's why it will never happen for the Earth. All right. So just remember some of these concepts. So that's why when it comes to Chang'e 6 mission, we see that Chang'e 6 mission right now, the current status of the Chang'e 6 mission is that the orbiter and the lander were launched. They entered the lunar orbit. The lander separated and they descended to what is called as the Apollo basin. And using a relay satellite, it extracted approximately 2 kg of lunar soil and transferred it back to the ascender. An ascender basically meaning that it will come out, and this ascender has taken off from this particular point. Then again, with the help of orbiter, the transfer of the samples to the returner capsule was done, and then it basically has come back to the Earth. It was in news just a couple of days back also. So so that's why just remember that these are some of the areas of discussion for us. So last 2-3 months, in the month of May, in the month of June, and in the month of July, this has been constantly in the news. So that's why we have to understand that this Chang'e 6 mission has a lot of important implications. For example, the far side samples are anticipated to provide insights into the moon's characteristics and also perhaps the planetary formation. At the same time, right now, detailed updates are not available, but first, what is expected is that the scientists from China will analyze the samples, and then after that, possibly they will share the same with international researchers as well. So that's why China's successful execution of lunar mission, it becomes very, very crucial because it places China at the forefront of lunar explorations. And they always also have the plans for the asteroid and Mars sample return missions by 2025 and 2030. So we have to see where it goes and how exactly the things are. Right. So let's move on to our next topic. InSpace announces pre-incubation program for aspiring space startups. Now, what basically we have seen here is that the Indian National Space Promotion and Authorization Center, that is InSpace, has launched the pre-incubation entrepreneurship, which has been, in short, has been called as the PI program. All right, PI. Why PI? Because it is pre-incubation, pre-incubation entrepreneurship. All right. So that's why we see that this kind of name has been given. So so in short, it is PI. Now, This is a kind of program which is aimed at supporting and nurturing some of the early stage space startups. That's why, to support and nurture early stage space startups, and at the same time, they will also try to cultivate and empower uh, the next generation of space technology innovators by providing them with the necessary tools and guidance to transform their space related dreams into their reality. So that's why, to empower the next gen space tech innovations is what they want. So overall, when it comes to this program, the program is going to span for 21 months in total, and it is divided into distinct phases like ideation, innovation, prototype development. So in all these cases, we'll see that there is a kind of structured support which is going to be provided at each and every critical stage to ensure that successful development of entrepreneurs' ideas can be done by in space. So overall, that's why when we look at this program, we'll see that they will provide all the important support that is needed. They will try to equip the young entrepreneurs with the kind of technical expertise and business acumen that is required in this particular sector. So that's why technical expertise and business acumen will be provided. Then also they will be helped to drive the exponential growth of India's space sector, because we have seen that overall India's space sector also has been doing very well in the past few years. And then we see that the number of space related startups also in India have been on a rise. So that's why we see that there are all these things that they'll try to look upon. And that's why, to unlock the potential of the innovative minds and also to contribute to India's leadership in the global space industry, is also one of the motives here. So that is basically what they are going to try as a part of this particular mission. So overall, they will try to also provide a kind of environment where collaborative learning can happen, and at the same time, we'll see that access to different kind of research institutions, incubators, academia, and prominent space industry players. Also, access to all of these also will be provided as a part of this program. So that's why we see that there are a lot of these things that we are looking at, and that's why the expected outcome here could be that it would perhaps promote a culture of innovation among the entrepreneurs in this particular sector, and hence it will help in also propelling, you can say in a manner, propelling the scientific advancements that generate the socio-economic benefits for India. So overall, it will also contribute to the broader economic development and also create a lot of new jobs and opportunities for people of India in space sector. So overall, these are some of the eligibility criteria that have been put forward, that it is for Indian citizens graduating in 2024 or already who have graduated. Then there should not be any kind of prior grants or funds or monetary support. Original work submissions have to be done, and early stage startups which have been registered with DPIIT, that is Department for Promotion of Industry and Internal Trade, on or after 1st of July 2022. They will also be classified as early stage startups. So they are also allowed. So there are all these things that we see as a part of this particular program. So will become a very, very crucial program as a part of India's or ISRO's initiatives to ensure that India's space sector develops as a whole. Right. So moving on to the next topic, Pushpak, ISRO's reusable launch vehicle clears test. Now, in this particular article, again, something that has been in the news for, you can say, last 4 5 months, especially since the March month, when the first another test was done in March. So then also it was in the news. So that's why it has been in the news since March. Now, what exactly are we looking at this place? We see that it has cleared the third and the final test in the series of LEX. So let's try to understand what exactly it is. Now, in this particular scenario, what we see is that last month on June 23rd, ISRO successfully conducted the third reusable launch vehicle landing experiment test. That's why LEX, landing experiment. All right. So that's why this is called as LEX-03, because this is landing experiment, third landing experiment. So now this was basically done at the aeronautical testing range, which is there in Chitradurga in Karnataka. And this basically has marked the final test in the LEX series that ISRO has had with regard to this Pushpak RLV testing. Now, the experiment basically has showcased the landing capabilities of RLV under more demanding conditions than the previous tests. So what we see is that this Pushpak, it was released from an Indian Air Force Chinook helicopter at an altitude of 4.5 kilometers. At an altitude of 4.5 kilometers with the help of Chinook helicopter, and this time this basically, you can say in a manner, this is where they have raised the altitude. Last time the altitude was approximately, I think, 1.5 kilometers, and this time it is 4.5 kilometers. So that's why they have increased the height this time. And now from this height, Pushpak has been able to correct its course automatically in on its own, approached the runway, and executed a very precise horizontal landing at the runway's center line. So that's what we have seen is that some of the challenges that basically they faced was that this time there was a very strong crosswind. All right, very strong crosswind that they had provided, the range of approximately 500 meters, which was just 150 meters in the previous LEX-02 mission. And the wind conditions also were way more severe this time as compared to last time. And that's why what we see is that in this particular scenario, they have been able to land with velocity which has exceeded 320 kilometers per hour. So that's why this time they have done the entire experiment in much harsher conditions as compared to the conditions that they had last time. And after the touchdown, what we see is that the vehicle slowed down to approximately 100 kilometers per hour using a brake parachute, and then also landing gear brakes were used. So, so we see that there are all these things that we saw as a part of this experimental mission. So overall, that's why we see that it has been a successful mission, because another thing that has to be considered here is that ISRO did not change a lot. I mean, it did not change anything for that matter, because what the vehicle, how Pushpak was used in LEX-02, in a very similar fashion, LEX-03 also has been conducted, and they did not change anything. Yet, with harsher conditions, they have experimented. Only the conditions changed. The vehicle was as it is for LEX-02 and LEX-03. So that's why you can say it's a very, very important, uh, it has been a very important development in reusable launch vehicle development of India. Now, coming to the next article, ISRO will launch first dedicated SSLV commercial mission in 2026. Now, what we basically see here is that there is a program which has been named as Space Maitri. Maitri meaning friendship in a manner, right? So, what we see is that last year, New Space India Limited, that is NSIL, NSIL, and which is also called as ISRO's commercial arm, it announced that there will be an upcoming first dedicated commercial launch of its new small satellite launch vehicle. Now, in this particular scenario, this particular launch is going to deploy a satellite called as Optimus. The name of the satellite is Optimus, which weighs approximately 450 kg, and this is an Australian designed and built spacecraft. Now, in this particular scenario, it's an Australia-based company called as Space Machines Company. Space Machines Company. This is an Australia-based company. Now, this announcement, it was made at India Space Congress, which was organized by Satcom Industry Association in India, and it marks a very significant collaboration between India and Australia in the space sector. Now, when it comes to this Optimus satellite, it weighs, as we discussed, it weighs 450 kg. It is the largest Australian designed and built spacecraft until now. Now, this mission, that's why the name of the mission has been given as Space Maitri, that is, Mission for Australia India's Technology Research and Innovation. And it has been scheduled for 2026. Now, this represents a very major milestone in the strategic partnership also between the two countries, which will try to enhance the collaboration among the commercial, institutional, and government space organizations between the two countries. So that's why we see that this is going to be a very, very important mission from perspective of India's commercial launches, as well as the relation between India Australia in space cooperation. Now, overall, what we also have seen is that before this, also there has been another commercial payload for SSLV, which was the Janus satellite, nano satellite, which weighed 10 kg in total, and this was carried out with SSLV D2. Now, just remember that D, whenever this term D is used by ISRO, D means demonstration. That this was a demonstration mission, but this time it will not be called as D, but rather C, because C is commercial, or C is in that sense. So that's why you will see that there will be a change in the name. So that's why this, when it comes to this Space Maitri mission, it aims to showcase the innovative space capabilities of the Australian company, that is Space Machines Company, and India's reliable launch expertise that has been developed over the years. So that's why this mission also aligns with the core values of both the countries, trying to promote responsible and sustainable practices in space. So that's why just remember the name of this particular mission. Moving on to the next article, space startup Agnikul Cosmos flies world's first 3D printed rocket engine in fifth attempt. Now, in this scenario, here we are talking about this launch that was done. Now, we are talking about a company, a space startup based in India called as Agnikul, right? Agnikul Cosmos. Agnikul Cosmos. Now, it has successfully launched its first suborbital test vehicle, and it has been named as Agni Band. Agni Band, all right? Agni Band sorted. Agni Band sorted. So as you can see, the name here, name has been written. So the name is Agni Band sorted. So in this particular scenario, so this is the name of this particular rocket. Now here what we see is that this launch becomes very, very crucial for also being powered by world's first single piece 3D printed rocket engine. Because see, when it comes to, so this is world's first 3D printed rocket engine. It is the world's first 3D printed rocket engine. Now, the vehicle, which has been lifted off from a private launch pad which was established by Agnikul at Sriharikota itself, this is very, very important because there are several milestones that we are looking at here. So when it comes to this Agniband sorted, now in this particular case, what we see is that this is powered by the first 3D printed semi-cryogenic engine. So the name, just remember that the name of this semi-cryogenic engine is Agni Lead. So Agni Lead is a semi-cryogenic engine. Now semi-cryogenic engine will be able to reduce the total cost altogether. Not only the fact that because it is semi-cryogenic, but also because of the fact that this is where the engine has been 3D printed. So otherwise what happens is that all the different engine parts, they are produced and manufactured separately, and then uh, they are assembled. So all that takes a lot of time and money. So but here we see that with this 3D printing approach, we'll be able to reduce the time, reduce the cost, and at the same time it will be a much better version of the engine altogether. So this mission, that's why this method of manufacturing, it reduces, just remember, cost and time both. Now, unlike the traditional engines, which also are assembled from multiple different parts, the 3D engine or the 3D printed engine is a single integrated piece. Now, the engine also uses, as we discussed, that it will be using a semi-cryogenic fuel, which is a sub-cooled oxygen as fuel, and that's what demonstrates a very crucial activity at the same time. And this launch also, because what we also discussed is that this is where we have been utilizing a private launch pad, and for the first time in India's private space sector, we see that there is a private launch pad being used. The infrastructure also supports the flexible launch options from any kind of location, which also will be using Agnikul's platform, mobile platform, which is called as Dhanush. Right, the name is Dhanush. So Dhanush, basically, just remember that Dhanush is what? Dhanush is a mobile launch pad. It is Agnikul's mobile launch pad. Right. So, so that's why we see that there are all these things, and Agnikul also plans to conduct its first orbital launch by the end of this particular year, with capability to carry satellites which will weigh between 30 to 300 kg. So that's why they also aim to offer regular launch services starting next year as well. So there are all these things that we are looking at when it comes to the private launches and the development of private space sector in India. Yeah. So moving on, the next topic that we have is Union Minister Dr. Jitendra Singh launches two geo portals. Now here, there are two geo portals that we are discussing. The names of these geo portals: one is Bhuvan Panchayat, and then second is National Database for Emergency Management. So these are the two portals. So what we basically saw was that Union Minister Dr. Jitendra Singh, he launched two new geo portals which have been developed by ISRO. All right, both of them, they have been developed by ISRO. So first is Bhuvan Panchayat and the second one is National Database for Emergency Management. Now, in this scenario, when it comes to these two portals, they provide high resolution satellite imagery at 1 is to 10K scale for visualization and planning across India. And firstly, when it comes to the Bhuvan Panchayat portal, it will be able to support decentralized planning by trying to provide real-time data to the citizens. And that's why they will try to reduce the reliance on local administration and maybe perhaps even corruption in the land record management. So that's why this is very, very crucial from that perspective. And when it comes to NDEM version 5.0, it is something that offers space-based inputs for disaster risk reduction in India, and not only in India, but also in neighboring countries. And that's why it will try to enhance the early warning systems and land use monitoring in terms of disaster as well. So that's why disaster risk reduction, enhancing early warning system and land use monitoring, India, for India, for India, and neighboring countries as well. For India and neighboring countries for both. So that's why we see that there are all these things related to it. There will be a command center also that they will establish, and this command center will continuously monitor and provide valuable inputs that are required to carry out any task. So these were some of the important areas from the sector of space. Now coming to some topics which are related to the energy sector. Now, the first topic that we have here is nuclear study provides major update on plutonium isotope fission. Now, what is it related to? Let's try to understand this, that what exactly it is related to. Uh, could be a bit of complex topic, so I'll try to break it down and slow it down. Where do we start? India, we know that India has been progressing into its nuclear power program. In March this year, on particularly on March 4th, India started working on a new type of reactor, and this type of reactor is called as fast breeder reactor. The name of that reactor is prototype fast breeder reactor. We started with fast breeder prototype fast breeder reactor. For those of you who have attended the regular classes of science and technology, I have already discussed about the fast breeder reactor. Now, here what we see is that when it comes to India's nuclear program, just to give you a bit of history and context, when it comes to India's nuclear program, we say that there are three stages. There are three stages of India's nuclear program, and by the time we are in the third stage, we will start using thorium. All right, we will start using thorium as our nuclear fuel. So, in the first stage where we largely have been until now, we are making the use of uranium. In the second stage, where now we have entered since March, we are making the use of plutonium. And when we are in the third stage in the future, when we reach the third stage in the future, we'll start using thorium. So the ultimate goal that India has is to start using thorium instead of uranium or plutonium in our nuclear reactors. Why thorium? The reason is that India has good amount of reserves of thorium. When you look at the worldwide data, you'll find that India is perhaps among the top 5 countries in the world when it comes to the thorium reserves. So that's why we want thorium, because uranium reserves are very limited in India, and that's why we import a lot of uranium. Plutonium is artificial. Plutonium is produced out of nuclear reactors. You do not mine for it. It is not a naturally occurring element. So that's why we want to reach a stage where we can start using thorium, because India has a lot of thorium, right? So this is what India's three-stage nuclear program is. So until now, we have largely been in the first stage, but since March, you can say that now it is a significant step, because with the start of prototype fast breeder reactor in Kalpakam, this is something that marks the second stage of India's nuclear power plan. So in the first stage, India has been using uranium to produce energy and to create a substance which is called as plutonium. So from uranium, if you look at this figure, from uranium, now what we want to produce is plutonium. So what we basically are doing now is we are producing plutonium, which is specifically plutonium 239, meaning that its mass number is 239. It has, as you can see in the picture also, it has 94 protons and 145 neutrons, adding up to 239 in total. Now, when it comes to when it comes to the second stage is where we are using plutonium 239 to produce more energy. Now, what happens in the reactor? When plutonium 239 captures a neutron, it turns into another type of plutonium, another isotope of plutonium called as plutonium 240. So plutonium 239 captures, or you can say absorbs, a neutron, and then it becomes plutonium 240, because there is one extra neutron now. So either this can happen, or it might split. If it splits, it is nuclear fission. So either nuclear fission will happen, or plutonium 240 will be created. So two things can happen. Either uh, it captures or absorbs a neutron and becomes plutonium 240, or it might undergo fission. Right? So there are two possibilities, either fission or plutonium 240. Now, if fission happens, it is something which is called as prompt fission neutron spectrum. We'll discuss what is this term, prompt fission neutron spectrum. This is a term that refers to the energy that has been carried out by neutrons that have been quickly released right after plutonium 240 captures a neutron. Now, scientists have been studying this to understand how much energy is produced here. So, so we'll discuss about what exactly this particular term is. Just hold on for some time. So what we know is that India now has initiated the second stage with prototype fast breeder reactor at Kalpakam, and this is where first stage we know that we are making the use of uranium in heavy water reactors to produce plutonium 239, and in second stage we focus on plutonium fission. So when plutonium 239 captures a neutron, it becomes or it might become plutonium 240, which can either undergo fission or even turn into plutonium 241. Now, the energy output from plutonium 240 is uncertain and estimated to use very complex models to even try and comprehend what kind of energy or how much energy could be produced from here. Now, what we see is that there have been new researches that have happened. There was a recent study that was conducted in the US that measured the energy from this quick neutrons in plutonium 240. All right. So we discuss about this prompt fission neutron spectrum. It represents the energy that is carried by neutrons emitted immediately after plutonium 240 captures a neutron. So two studies have measured this for plutonium 240, and recent findings have shown significant differences from the prediction. Now, what exactly is the difference that they have shown? So new research, there was a new recent study that was conducted in the US, and it measured the amount of energy that these kind of quick neutrons which are there in plutonium 240 they would release. They found differences between what they expected and what exactly they actually measured, which is important for also improving the nuclear reactor designs and also for some of the other applications. So when we look at plutonium 240, plutonium 240 can either split by itself, which is spontaneous fission, and release particles which are called as alpha particles. And although it is not desirable in weapon grade plutonium because it makes the material very less suitable for weapons. Now, in this context, when it comes to the new findings are very, very important for updating the database that the scientists have been using to predict the nuclear reactions. And these kind of databases, they help them in designing reactors, in medical treatments, in understanding of the nuclear processes, and all these kind of things. So that's why we do understand that this entire thing becomes very, very crucial in this context. And that's why, just remember all, let me just also summarize for you. It could be a bit confusing for you, so let me just summarize everything. So what we know is that we have uranium, right? So from uranium 238, what we get is plutonium 239, right? What we get is plutonium 239. Now this plutonium 239 can undergo fission or can absorb a neutron and become plutonium 240. All right, it can become plutonium 240. Now, if it becomes plutonium 240, the same can happen with plutonium 240 also, that it can undergo fission or it can form plutonium 241. So in this particular scenario, what we see here is that when it comes to this kind of fission, very quickly this kind of fission can happen, and very quickly it can release a lot of energy. And this is something what we call as prompt. All right, this is what we call as prompt fission, prompt fission neutron spectrum. Now, prompt fission neutron spectrum refers to the kind of distribution of the energy of the neutrons that are emitted immediately following a fission of a heavy nucleus, such as plutonium 239 or even uranium 235. So, when heavy nucleus undergoes fission, it splits into two or more smaller nuclei. This you know, this is what fission is, splitting, right? So, when any heavy nucleus undergoes fission, it splits into two or more smaller nuclei. Now, when this happens, what we see is that they release a number of neutrons among some of the other particles and energy as well, but they release a number of neutrons, and these neutrons are termed as prompt because they are emitted almost instantaneously during the fission process within. So what we see here is that neutrons are emitted instantaneously. I mean, just to give you data, not important for your examination, but within 10 to the power of minus 14 seconds. So within such a short time. So that's why these neutrons are termed as prompt, right? That's why these neutrons, they are called as prompt because they are being released quickly. All right. So so what we see is that they are not getting delayed in any case, and they are related very quickly. They are emitted very quickly. Delayed neutrons are the ones that happen in radioactivity. In radioactive decay, the neutrons that are emitted, they are delayed. Now, in this particular scenario, when it comes to this prompt fission neutron spectrum, it becomes very crucial in nuclear reactor physics and nuclear weapon design for various different reasons. What we see is that the energy distribution of the prompt neutrons, it influences the chain reaction in a nuclear reactor. And that's why understanding of this process also helps in accurate modeling of the reactor behavior, and that's why they also affect the fuel burn up rates or the reactor control and even the safety systems that we are trying to design. They also help us in determining the critical mass of the fissile material and for also performing the criticality safety calculations as well. Many times during the lectures and in the past also, when I've taken current affairs lectures, I have talked about criticality. If you go back to even December 2023 newspaper, you'll find that criticality has been discussed in the Hindu newspaper, and criticality is very crucial. And these neutrons, they help us in understanding criticality as well, determining criticality as well. So that's why we see that there are a lot of important activities where these prompt neutrons would help. So that's why we see that this time there is a study, and the study has reflected newer data which we did not know of until now. So that's why it might give us insights into a lot of things that perhaps are unknown to us, and it might give us uh, maybe better insight into fission reaction altogether. So that is what this is all about. So overall, this is the study that was conducted, and they found deviations in predicting these processes. Now, moving on to the next topic, and this is about gasification. There are two news articles that we see in the PIB last month related to coal gasification. So one is about a workshop called as Caring 2024, and then the first ever pilot project for underground coal gasification in Jharkhand. So these are the two news articles or two news that we see in PIB. Now, coming to what exactly is this workshop. So workshop is something that has been organized by CSIR. Now, CIMFR is Central Institute of Mining and Fuel Research. All right. So CSIR stands for Council for Scientific and Industrial Research, where a part of it is CIMFR, that is Central Institute of Mining and Fuel Research. So they conducted a 2-day workshop called as Caring 2024, focusing on coal gasification challenges and opportunities. Now, this was carried out in the Digwadi campus of CSIR. Now, this basically is where we saw that a lot of people from industries, uh, industry leaders, researchers, policymakers, stakeholders to delve into gasification technologies, complexity, and the potential, they all came together. There were approximately 75 different organizations like Coal India Limited, or Steel Authority of India Limited, that is SAIL, or even Jindal Steel and Power Limited. They also had come there. Hindalco was there, Thermax was there. So we see that there were all these big participants who were there in the workshop, and that's why it was a landmark event in coal gasification in India, you can say, altogether. So that's why it was highlighted that when it comes to the government, and there is an 8500 crore government allocation for gasification projects in India, and overall the technology's importance in achieving India's energy goals and also trying to enhance energy security, aiming at approximately 100 metric tons of coal gasification by 2030 is what we want. So overall, that's why we see that there are all these things, and that's why this workshop was conducted, so that it could foster collaboration and innovation, knowledge sharing among all these participants. So that's why it provided a platform for discussing the advancements, to also address the challenges, and also to explore the opportunities in gasification technology, contributing to India's energy security and sustainability for the future. So that's why we see that it becomes a very, very crucial workshop altogether from this perspective. Now, secondly, we see that there is the first pilot project about underground coal gasification that was carried out in Jharkhand. Now, what is coal gasification? Again, something that in the regular classes, for those of you who have already attended, we have discussed, but let me just discuss it for the rest of you. Coal gasification. Gasification means that we are gasifying coal. All right. We are gasifying coal, meaning that we are converting coal into gas. We are converting coal into gas. Converting coal into gas. What kind of gas? This is called as syngas. Syngas, which largely is a mixture of hydrogen and carbon monoxide with, you can say, small amounts of carbon dioxide also present, methane also present. So all these can be there. So as you can see that it will be converted into valuable gases like methane, hydrogen, carbon monoxide, carbon dioxide, etc., for various industrial applications. So it is something that can be used for electricity generation. It will give you cleaner energy as compared to the normal combustion of coal that we usually do in thermal power plants. So compared to that, coal gasification gives you cleaner energy, cleaner electricity. But at the same time, in various manufacturing plants also, we make the use of coal gasification. For example, even in fertilizers, in manufacturing fertilizers also, coal gasification becomes useful. So that's why we see that there are all these things with regard to coal gasification. And just remember about this workshop, and just remember this as a fact, that first pilot project for underground coal gasification in Jharkhand now has been done. So there are two phases in which this coal gasification will be done in Jharkhand. First, first phase is going to be more of research and understanding, and second to implement them and do better. So this is basically what we want out of it. Now, coming to the next topic, and the next topic is Cabinet approves viability gap funding scheme for implementation of offshore wind energy projects. The scheme aims to set up first ever offshore wind energy project in India. Again taken from PIB of last month. Now, what we see is that the Union Cabinet, which was chaired by Prime Minister Narendra Modi himself, it approved viability gap funding scheme for offshore wind energy projects with a of approximately total outlay of approximately 7,453 crores. So out of which 6853 crores for 1 gigawatt project and 600 crore for port upgrades. So that's why we see that this now has been approved by the government of India. Now, before we move on to what has been done and what is being done, what is offshore wind energy? Usually the wind energy farms, if you go around, you might see that there are wind energy farms which are located in areas which have wide open spaces, largely near the coastlines, etc. Those are onshore wind energy farms. With offshore energy farms, what we want is that we would place the wind farms on the bodies of water, largely in the continental shelves. All right, largely in the continental shelves. I don't know whether this color is visible or not. Let me change it on continental shelves. Now, in this particular scenario, when it comes to the offshore wind, that's why on the body of water they are being constructed. Now, construction of offshore wind energy farms are not as easy as the onshore ones. The ones that you are laying down on land, they are much easier to construct compared to the ones that you lay on bodies of water. Now, India now wants to delve into this, and we want that India should have offshore energy projects for the future. So this is where the first of the projects are being taken. So the first project, for example, where we see that we talk about 6853 crores for 1 gigawatt projects. These projects, there will be two projects of 500 megawatt each. Two projects of 500 megawatts each, one in Gujarat and the other one in Tamil Nadu. All right. So these are the two projects that we are starting with, and 600 crores for port upgrades. So port upgrades meaning to support the logistics for these kind of projects. Now, when it comes to this project, we are talking about something called as viability gap funding. Viability gap funding. Now, this viability gap funding scheme is very significant move towards implementing the National Offshore Wind Energy Policy of 2015 also. And that's why it will aim at harnessing of the offshore wind energy, which has an extensive potential in India when it comes to the exclusive economic zone of India. Now, when it comes to the viability gap funding is a kind of scheme that the government of India provides to certain schemes only, certain projects or certain, you can say, policies, where they understand that the total amount of money that they need to give, the total amount of financial support that they need to provide to a certain initiative or policy is bigger than or more than what they initially thought. And they see these kind of projects to be strategically very, very important. So for all these projects which are strategically important for India, you can say additional financial support is provided through maybe direct finances or maybe tax rebates, direct or indirect tax rebates, so in any form. So whenever they are providing extra support, when they are providing extra financial support apart from the budget that was already kept, that is called as viability gap funding. So the government's financial support is something that will also reduce the power cost from offshore wind projects, and that's why it will make it viable for purchase by the discoms or the distribution companies as well. So That is basically what we see here. And overall, we see that the private developers selected through the bidding process will also establish the projects. And while when it comes to the PGCIL or Power Grid Corporation of India, will try to construct the power excavated infrastructure, excavation infrastructures, which would also include the offshore substations. So what we overall see is that the Ministry of New and Renewable Energy will try to coordinate with the various ministries and the departments to also try and ensure the scheme's successful implementation altogether. And specific port infrastructure is also required for the construction and operation of these offshore wind energy projects, which should be capable of handling large and heavy equipments. So that is where the other 600 crore is going. So that's why the Ministry of Ports, Shipping and Waterways will also try to support the development of two ports to meet these kind of requirements. So offshore wind energy is something that offers a lot of advantages over the onshore ones, even over solar energy projects as well. For example, they have higher adequacy and reliability. They have lower storage requirements. They have higher employment potential as well as compared to the onshore wind energy projects or even solar energy sector altogether. So 1 gigawatt projects will produce 3.72 billion units of renewable energy annually. An annual reduction of 2.98 million tons of carbon dioxide emissions will happen over the next 25 years. So that's why these are significant numbers that we want to achieve in the field of uh, offshore wind energy. And that's why we see that overall initial 37 gigawatt offshore wind energy development projects with 4,50,000 crore investment will also be taken up. So that's why just remember that there are a lot of advantages because of which we are looking towards offshore wind, right? So what kind of advantages? Better reliability, just remember that this is a major factor. Lower storage requirements, and at the same time they have a better employment potential. So there are all these factors that we have to understand from the perspective of the offshore wind energy projects. So that's why it becomes crucial. And this the development of this sector, you can say, I'll add to those points only. The development of this sector is also expected to attract more investments, right? So you can say more investments will be attracted here, more investments. Largely, you can say some of the green investments as well, right? Some of the green investments as well, and then enhance the indigenous manufacturing capabilities as well, right? uh, Enhancing indigenous manufacturing capacity. So that's why there will be a lot of these things that we see, and technologically also it will help in providing better way for the future. So that's why this contributes to India's energy transition targets as well. The successful commissioning of 1 gigawatt offshore wind projects, as we just discussed, will be able to produce 3.72 billion units of renewable energy electricity annually, which will be able to reduce 2.98 million tons of carbon dioxide over the next 25 years annually. So that's why this scheme will kickstart the offshore wind energy development in India and create an ecosystem to support the ocean based economic activities in India as well. So, overall, that's why it is expected to aid a development of a total of 37 gigawatt offshore wind energy projects, an investment of approximately 4,50,000 crores in this particular sector in India. So that's why just remember all these points with regard to this. And also we discussed about the national offshore wind energy policy. National offshore wind energy policy. Now, this is not a new policy, but a policy that was introduced back in 2015 itself, coming with a lot of expectations and encouraging the investments and promoting the spatial planning, management of the maritime resources, uh, uh, using of the energy resources of India, improving the, you can say, renewable energy condition in India, attaining energy security for India, reducing the carbon emission. So there are all these things that were taken as a part of national offshore wind energy policy. So in a manner, you can say that all these are related to the national uh, wind offshore wind energy policy of 2015. Now, moving on to the next segment, and this is the segment related to diseases. Now, when it comes to the diseases segment, or sorry, we'll discuss things related to biology, biotechnology, and diseases all together. So, first is multi-omics is changing how India spots and treats TB or cancers. Now, what are we talking about? What do we mean by multi-omics? Let's try to understand this. Now, in the last decade, what we have seen is that India has made significant strides in genomics, transforming the diagnosis, the management, the treatment of various diseases, including tuberculosis, including cancer, and those also caused by the antimicrobial resistance also. And that's why there have been various different projects. For example, there has been the Genome India project, right? There is the Genome India project. Genome India project. So in January this year, January 2024, the Department of Biotechnology had announced completion of sequencing of 10,000 genomes, completion of 10,000 genomes from 99 ethnic groups. 10,000 genomes from 99 ethnic groups under the Genome India project. Now, this initiative is something that aims at creating a reference genome for people of India, and that's why facilitating the design of low cost diagnostics and research tools in India. So, that's why this we have seen that it has been in the news. Then, apart from that, before this, we see that there was the Indigen mission, right? So, there was the Indigen mission. Now, Indigen Mission, this is back in 2020, the Council for Scientific and Industrial Research, CSIR, it sequenced the entire genomes of 1008 individuals from diverse ethnic groups. So, this was carried out by CSIR, where they took 1008 1008 genomes, all right, entire genomes of 1008 individuals. Wait, let me write 1008 individual genomic sequences. Now, the Indigen mission basically aimed at providing or analyzing the, uh, you can say, epi epidemiology of genetic diseases and developing affordable screening methods, and also trying to optimize the treatments and minimize the adverse effects that we see altogether. So that's why we see that there have been projects like this. Now, when it comes to what do we even mean by multi-omics approach, researchers basically are trying to leverage artificial intelligence and machine learning to extract more value from the genomic data and integrating it with various different types of concepts like proteomics or transcriptomics and epigenomics. So there are all these things that they are trying to tackle the disease more effectively. So this is where they are trying to utilize artificial intelligence and the various aspects of artificial intelligence like machine learning to do that. So when it comes to this multi-omics approach, The multi-omics approach refers to the comprehensive method in biological research that integrates the various different types of the omics data, such as genomics or proteomics or transcriptomics or epigenomics, to try and gain a more holistic understanding of the biological systems and processes. So that's why this is basically what we try, that we are trying to integrate the genomic data from all these different branches. So for example, if you try to understand what do we even mean by this multi-omics, so first basically is genomics, right? We are trying to use genomics. So what is genomics? The study of genes, right? The study of an organism's complete set of DNA, including all of its genes. And that's why it focuses on the structure, the function, and the evolution and mapping of the genome. So in a manner, you can say that this is nothing but the study of genes. Study of genomes, let me say study of genomes, that is the entire set of genes. Then after that you have proteomics. So proteomics, when it comes to it, it is the large scale study of proteomes, which basically are the entire set of proteins that are produced or modified by an organism. So that's why this is a field that looks at the structure and function of proteins, as well as how exactly do they interact within a biological system. So so first is genomics, then you have proteomics. Proteomics. So proteomics is what? It is basically uh, the uh, the study of proteins. All right, the study of proteomes. Let me say proteomes. That is, you can say the entire set, the which are the entire set of proteins, entire set of proteins, entire set of proteins which are produced or modified by an organism, right? So proteomics. So that's why this becomes very, very crucial, because they would try to understand how the proteins are made, what they are modifying, how they are modifying, what the folding of protein is like. So all these things. And then after that, you have the transcriptomics. So transcriptomics basically is the study of the transcriptome, the complete set of RNA transcripts which are produced by the genome at any one particular time. So that's why it is something that helps in understanding of the gene expression patterns and the regulation of the genes. So that's why transcriptomics. Transcriptomics. So transcriptomics basically is the study of transcriptome. Right, study of transcriptome, which in a manner you can say the complete set of RNA transcripts which are produced by genomes at any one time. So this is what complete set of RNA, complete set of RNA transcripts, complete set of RNA transcripts produced by genomes, by genome at a time. All right. So, or any one time. So that's why it helps in understanding of the gene expressions and the patterns. If you know, if you have gone through the previous year questions, I think it was 2017 prelims when they asked the meaning of what is transcriptome. So already asked in your prelims paper once. Then after that, there is epigenomics. So epigenomics is the study of complete set of epigenetic modifications on the genetic material of the cell, which actually can influence the gene expression without changing the DNA sequences. So these kind of modifications, they include uh, uh, you can say different kinds of modification or the non-coding RNA molecules, etc. as well. So by integrating the data from all these various omics fields, researchers can actually obtain a more detailed and interconnected view of how the genes, the proteins, and all the other molecules they interact, and how do they regulate the biological processes. So that's why this comprehensive perspective is something that can also lead to a better understanding of the complex diseases and the discovery perhaps of new biomarkers, and maybe the development of personalized medicine approaches as well. So there are all these things that they can do, and that's why when we look at this particular approach, we do understand that it can provide various different benefits. So, for example, tuberculosis genomic surveillance. Uh, the Indian Tuberculosis Genomic Surveillance Consortium is working to sequence approximately 32,000 tuberculosis clinical strains from active patients. So, in this case, what we see is that this project is something that is aiming to map the genetic diversity of tuberculosis bacteria and correlate the mutations with drug resistance, and also develop the sequence based methods to determine the drug resistance as well. Then, apart from that, when we look at the pediatric rare genetic disorders, we see that the pediatric rare genetic disorders is a mission that is trying to aim to raise the awareness, uh, and at the same time provide the genetic diagnosis, discover new genes, and also provide counseling and develop therapies for rare genetic diseases in children. So this mission is something that incorporates data from the Indigen project and also involves multiple different centers across India to try and identify some of the novel genes and also the variants. So that's why this is what we see. Then in cancer genomics, what we have seen is that the Indian Cancer Genome Consortium, they aim to characterize the genomic abnormalities in different cancer patients in India, identifying the population specific genetic variations also which are linked to cancer risk and the treatment response as well. So there are all these things that we see. Then there is, if you know, there is the Indian Cancer Genome Atlas project also. I'm writing it down. Indian, just remember this, Indian Cancer Genome, Indian Cancer Genome Atlas project. All right. This is something that is cataloging the genomic alterations which are seen across the various different types of cancer to try and aid in identifying the biomarkers and the treatment targets. Then, apart from that, we see that even in case of antibiotic resistance, in case of antibiotic resistance, all right, in case of antibiotic resistance, what we have seen is that genomics and metagenomics, they are used in trying in analyzing the antimicrobial resistance, in trying to provide the information on resistance profiles without the need to grow any kind of microbe in the lab. So that's why it helps in the clinicians to make informed decision about the antibiotic use, particularly for the slow growing pathogens like, for example, the tuberculosis bacteria. So there is all these things. Plus, we see that there is the use, as we discussed about, the use of artificial intelligence and machine learning, or even big data. Uh, Big data in genomics. What we have seen is that artificial intelligence becomes very essential for analyzing large genomic databases and in predicting the disease risk, in developing the diagnostic tools, and the kind different types of treatment strategies as well. So these kind of technologies, they would facilitate the analysis of the massive sequencing data and try to enable the rapid and you can say sorry, accurate identification of the disease causing variants, and also try to enhance the multi-omics approaches in the clinical science. So that's why when it comes to India's advancements in genomics, which are also driven by national initiatives and cutting edge technologies of late, they are poised to also revolutionize the healthcare sector by perhaps providing personalized and precise medical solutions, in the country. So that's why there are all these things, and they become crucial from the perspective of your examination. Coming to the next article, WHO confirms H9N2 bird flu in India in 4-year-old. Here's how it affects kids differently as compared to adults. Now, what we see here is the case of bird flu. The World Health Organization recently reported a case of human infection with H9N2. H9N2 bird flu virus in a 4-year-old kid in West Bengal, which marks the second documented case in India. The first case occurred back in 2019. Now, the child was admitted to a pediatric ICU with very severe respiratory issues, high fever, and also abdominal cramps in the month of February, and was discharged in the month of May, I think. Now, when it comes to H9N2, it is a subtype of influenza A virus. You might know that. Any kind of bird flu, swine flu, etc., they are all largely a part of influenza A virus. So, this is also a subtype of influenza A virus. Influenza A virus. Now, in this particular scenario, it is something that primarily affects the birds, but also has been seen to infect humans as well. When we look at H9N2 virus, what we see is that this is primarily going to affect the birds, especially in poultry, but can also affect humans and other mammals as well. Now, when it comes to the transmission can either happen with direct contact with the infected bird, or maybe due to contaminated environment, or possibly some of the other routes as well. So, first thing is that we know that primarily birds or primarily poultry, right? And then after that, it can if affect humans also. Can affect humans. It can affect humans as well. Transmission can happen with direct contact. Transmission can happen with direct contact, right? Direct contact, or maybe contaminated environments as well, or contaminated environments. Now, what we have seen is that globally, although they have been found, but largely the cases have been reported in Asia and Africa, and some parts of Europe as well. Now, what kind of symptoms do we see in humans? So, largely what we have seen is that there are respiratory symptoms similar to those which are caused by other influenza viruses. For example, fever, cough, sore throat. Sometimes severe respiratory illnesses can also happen. Some of the other symptoms can also be there. For example, there can be muscle aches, there can be fatigue. Sometimes gastrointestinal symptoms can also be seen, like diarrhea can also be a symptom. So there are all these symptoms that we see in case of this. So symptoms. So cough, sorry, fever, these kind of can be there. Then sore throat, as I just discussed, that sore throat can be one of the symptoms. Then apart from that, there can be fatigue, there can be muscle pain, all right, there can be muscle pain, and sometimes even gastrointestinal symptoms like diarrhea also can be could be possible. So that's why we see that there are all these symptoms which are possible in case of H9N2. So overall, we'll have to limit the exposure. Avoiding live poultry and bird markets is crucial. A frequent hand washing is required, especially after interacting with birds or their habitats. So these kind of things will be done. Annual flu shots can be also taken, but although they would have limited scope, using mask and gloves while especially handling the birds is also required. So there are all these things. Diagnosis wise, what we see is that there is an RT-PCR test that can be done, and this RT-PCR test can detect the viral RNA. The throat and the nose swabs for virus isolation can be done, and that is where we get it from. Then there are antiviral drugs also, like oseltamivir is there, or zenamivir is there. So these kind, they can be effective if they have been started early. So there is oseltamivir, all right, or there is the zenamivir. So these kind of antiviral drugs can be used. So there are all these things that can be done, but overall we see that these, although they are not as frequent as some of the other viruses in case of bird flu, but even in this case it has been seen. Now, what is the difference in children, as has been given in the article also? Children very often have milder symptoms, but they are more susceptible to severe complications due to their developing immune system. They are more likely to come into contact with birds during maybe playing, for example. So it increases their risk of infection. So that's what the general advice given for the parents is that they should monitor the children for flu-like symptoms if they have been around birds. Keep children away from areas which are known with bird flu outbreaks. Ensuring good hygiene practices and understanding these kind of aspects of H9N2 bird flu will help them in effectively preventing or diagnosing or even treating the infections, especially in vulnerable populations like children. So that's why there are all these things that we should know with regard to H9N2. Coming to the next article, scientists find the largest known genome inside a small plant. Now, what we see is that there is a new research that was done, and the new research has found that a fern species, a fork fern species, which is called this. You can try and uh, pronounce it. I'm not going to do that and make it difficult for you. So uh, now this basically has a genome that is 7% larger than that of the previous record holder, which was a Japanese flowering plant. All right. So there is a Japanese flowering plant which is called as, this is an easier pronunciation, so that's why I'll say it, Paris japonica. So previously the record was held by Paris japonica, and this particular fern, it has 7% larger genome as compared to Paris japonica. Now what is significant here is that the genome size of this fern is approximately 50 times larger than human genome, right? 50 times the size of human genome, because previously we used to think that that the human genome is the largest genome because we are complex individuals, but then we found that that's not the case. And then now there is the newest discovery that this particular fern has the largest genome in the world. Now this basically is a rare species of fern which grows primarily on ground and atop fallen tree trunks, and also uh, in some of the areas of uh, the world. For example, we see that uh, New Caledonia is island nation of New Caledonia is where it primarily grows. Then apart from that, we see that neighboring islands also is where they have been found. It's a very small plant, typically just 10 to 15 centimeters in height. So it's just 10 to 15 centimeters in height. And then, but the record breaking genome size is what we have seen here, that overall there are 160, to be exact, 160.45 not million, sorry, billion base pairs is what it has. Right, so that's why this is what makes up one strand of its DNA. So overall there are 11 billion more than the previous record holder, the Japanese flowering plant, that is Paris japonica, and as I told you, 50 times more than the human genome. If stretched out like a ball of yarn, the length of this DNA in each of this fern would extend nearly to 350 feet, or you can say 106 meters altogether. The human genome would extend just approximately 2 meters. So just imagine this, that human genome is 2 meters long if stretched, and this is how much? This is 106 meters long. So that's why we see that this is where we see with it. Now overall, so just remember that it's a kind of fog fern which has been seen, and largely it has been restricted, the distribution is restricted to the Australia or Oceania region, several Pacific islands, etc. So it is a kind of fern. What is a fern? Fern, you might know that these are plants which do not have flowers. Similar to the flower, they are similar to the flowering plants, but ferns basically have roots, stems, and leaves, but they do not have flowers. All right. So that's why just remember that these are plants without flowers. So unlike flowering plants, ferns do not have flowers or seeds. Instead, they usually reproduce actually by tiny spores, or sometimes they can reproduce vegetatively as well. So that's why they are different from normal flowering plants. Then after that, uh, the next topic is how will AlphaFold 3 change life sciences research? Now, AlphaFold 3 again has been in the news constantly. In the month of May, also it was in the news. Again, in the month of June, it has been in the news. So, what is AlphaFold 3? Let's try to understand that. But before that, proteins, all right, because it is about proteins. So, we know that proteins are essential molecules in the biological systems, and they would regulate nearly every function of the body from the birth until the death, and they are composed of amino acids. Right, there are amino acids, and these amino acids which determine the protein's final 3D structure through very complex folding processes. There is something called as the protein folding. All right, so proteins fold into a complex 3D structure. Now, the intricacies of protein folding, which is also known as the protein folding problem, for very long, they have puzzled the scientists. As understanding of the protein shapes is very crucial for comprehending the cellular and organism functions. So that's why we understand that proteins are very, very crucial. And at the same time, we need to understand what is protein folding. So protein folding is the process by which linear chain of amino acids acquire their three-dimensional functional structure. All right. So what are we saying? That these amino acids, they would be forming, or they would be folding, and the linear chain, they, as you can see, that linear chain means what, that they are like one single chain. So this kind of a linear chain that you see right here, this linear chain acquires the three-dimensional functional structure. So that is called as protein folding. So let me write it for you, it's a bit of complex topic. Protein folding. So what do we mean by protein folding? So protein folding basically is protein folding is the process by which the linear chain of amino acids, they acquire the 3D, it's three-dimensional or 3D functional structure. So this is called as folding. Now, what exactly happens that we have the amino acid sequences. So proteins start as linear chains of amino acids, which are linked together in a specific sequence. Now, the primary structure, basically the specific order of the amino acids in the chain, which is also known as the primary structure, contains all the information necessary for the protein to fold into its functional form. So that is where it starts from. All right, that is where it starts from. So every protein is made up of sequence of amino acids which are bonded together. Then comes the secondary structure. So it starts with the primary structure. So primary structure is where we are talking about the specific order of amino acids in the chain. All right, this is basically the specific order, right? The specific order of amino acids. So this is called as the primary structure. Now after that we have the secondary structure. Now in the secondary structure, localized folding patterns within the protein chain, such as something called as alpha helix and beta sheets, which are stabilized by hydrogen bonds, they are formed. So that is basically what happens now. So as you can see here, so this is the primary structure. All right, this is the primary structure, and this is where you have the secondary structure. So now in secondary structure, what we see is that they form helices and sheets. So this kind of alpha helix and beta sheets, they are formed. So that's why we see that there are localized folding patterns. All right, there are localized folding patterns within the protein chain, within the protein chain such as alpha helices. All right, you have the alpha helices or beta sheets. So these are stabilized by hydrogen bonds, and then after that comes the tertiary shapes. So what we see is that the overall three-dimensional structure of a single protein molecule, which are formed by the folding of the secondary structures into a compact shape. Now, this folding is something that is driven by various interactions, including the hydrogen bonds or ionic bonds, or there are forces called weak forces called as van der Waals forces. So all these kind of interactions will lead to the formation of the tertiary structure. So this, you can say, this is the tertiary structure. This is the tertiary structure where we see that the three-dimensional structure of a single protein molecule, which is formed by the folding of secondary structures into a compact shape, finally is done. So that's why this becomes very, very crucial, because here when it comes to the tertiary structure, right? When it comes to the tertiary structure basically is the three-dimensional, just remember, three-dimensional structure of single protein molecule, formed by folding of the secondary structure. All right, secondary structure. So as you see here, now what has happened is that all these So as you can see that all these helices and all these sheets, they now have formed a three-dimensional shape. All right, they formed a three-dimensional shape. So this is called as the tertiary structure. And then finally you have the quaternary structure. All right, so this is where you have the quaternary structure. So when it comes to the quaternary structure, this is where we see that some proteins that consist of multiple folded uh, polypeptide chains or subunits which come together to form larger functional complexes altogether. So we see that now we have this kind of a structure that these proteins will interact with other proteins and then they will uh, basically form the entire DNA and the genomes, etc. So ultimately, we see that the final folded structure allows the protein to perform its specific biological function. So now when the quaternary structure is completed, this is where the functions of the protein will start. That the protein will start doing its job, what it is supposed to do in any biological form. Now, in this particular scenario, what we see is that uh, folding correctly is very, very important. That if, let's say, when proper folding happens, it is very crucial for protein's functionality. Any kind of problem in folding, any misfolding, can actually lead to non-functional proteins or harmful aggregates, which actually can also be associated with various different types of diseases, even with diseases like Alzheimer's or Parkinson's. All these kind of things can happen if the folding does not happen correctly. So that's why protein folding is something that is influenced by the cellular environment and is also assisted by the molecular uh, functionalities altogether, and that's why they help protein fold they help in folding of the protein correctly, and that's why they prevent the misfolding on any kind of aggregate. So that's why understanding of protein folding becomes essential. Understanding of protein folding becomes essential for biological insights, for understanding the biological processes. And that's why traditional methods struggled with the prediction of the protein structures, which has been a challenge. That which we call as the protein folding problem, that we don't understand how the proteins fold. We don't have a better good understanding of how the proteins fold. So that's why we see that there are a lot of issues with our understanding. Now, to overcome that issue is where comes AlphaFold. In 2020, in 2020, Google DeepMind AI-based tool predicted protein structure for the first time. From the amino acid sequences, they were able to predict the folds. They were able to predict the kind of protein folds that happen. And then in 2021 came AlphaFold 2, which was able to improve the accuracy in predicting the protein structures. Now, overall, after, so these have been the first two. Then after that comes the protein fold, sorry, that is AlphaFold 3. Now, when it comes to AlphaFold 3, which is a recent advancement and it was introduced in May 2024, what we see is that it is not only something that predicts protein structures with higher accuracy, but also anticipates the interactions between the proteins, DNA, RNA, and all the other molecules. The advancement has, you can say, in a manner, democratized the research, and it has enabled the scientists without machine learning expertise to predict the molecular structure using a simple interface, that is AlphaFold 3. And that's why AlphaFold's development has relied upon extensive training, which has used protein data bank sequences and structures. And that's why we see that they have been able to come out with this particular scenario. So overall, AlphaFold 3 employs a very diffused model and training of the AI that has led to the better understanding of protein folds. And we see that the accuracy levels are very, very high. And not only accuracy, they are accurate, but they will also be able to predict, right? They will also be able to predict the protein folds. So that's why it becomes very, very crucial, because until now our protein folding understanding has been pretty bad, and with AlphaFold 3 all that changes. So that's why we have to see where exactly it goes, because currently AlphaFold 3 is utilized by academics and companies such as the DeepMind's lab, or in drug discovery also it is being used. But the access to the full model code is something which is restricted. And that's why it has been frustrating the researchers who wish to modify it for certain specific use. So in response to these kind of criticisms, what we see is that DeepMind has committed to release the full code for the academic use within the next 6 months. So while AlphaFold 3 is something which becomes a very powerful tool for predicting the molecular structures and also the interactions, the scientists have cautioned against treating of these kind of predictions as an absolute truth. So that's why, in a manner, you can say that it serves as a starting point for further experimental validation and hypothesis for testing and enhancing or even understanding of molecular biology. So this is about protein folds. We are actually left with a lot, almost half an hour or so. Uh, Let me do this because there are these topics. I don't want to hurry into these topics, into just explaining through these topics. Let me take some more time whenever the class schedules are free, and I'll take up all the remaining topics as well, because there are almost 5 6 topics which are left, and talking about those 5 6 topics might take up to perhaps 45 minutes of time, which may not be ideal for you. So let me take another small session sometime and complete it. Any questions if you have? Any questions if you have with regard to the discussions that we have done? Although I see that the subject matter experts have answered many of your queries already. Previous month webinars, I had taken, I think, April month webinar as well. May month, I don't remember whether I had taken, because I was on a long leave because of some personal medical reasons at home. So now I have returned, so I'll check what's pending. Seeing you live after a long time. Yeah, I was on a long break. There were some medical issues at home because of which uh, I was not here. Excellent explanation. Thank you so much. Covaxin IPR, as I told you that there are certain issues that, I mean, there are certain topics which are left. I'll discuss all those topics as well. So, for example, nitroplast is one topic. Uh, this VEG FR1 is another topic. Then defense related, there are two topics, and then Covaxin IPR. So, there are all these topics that are left. Offshore and onshore. See, offshore is when you are doing something on the body of water itself, that is offshore. When you're doing on land, it is onshore. Webinar is for prelims or mains, for both. Not able to understand science and economics webinar properly. This is expected, that science and economy are always going to be the two most difficult topics. Go through the webinars again, revise it again, and if you find any issues, if you want to ask anything, you can even write to me directly as well. This is my email ID, rasesh.kumar@byju's.com. Transfusion basically is when you are, let's say, taking something from one place to another. So blood transfusion, for example, when you are transferring blood from one person to another. Yeah, from my previous class, I know that there is some topic left. I'll try to find some time, because now I have returned, so I will be available. So I'll conduct the classes whenever the schedule is free. Is webinar essential to listen, or PPTs will be enough? No, PPTs can never be enough. PPTs are indicative. Largely, it is everything that we have been discussing. The discussions are important. Coal gasification disadvantages. Disadvantage wise, one thing that you can say is that it already uses a lot of energy to gather that energy, because you need to raise the temperature to almost 1200 to 1500 degrees Celsius. For that also you need a lot of energy. So that's why what they say, that the amount of positives that they say about coal gasification is a little lesser than that. Right, so let's end the session. Already I've taken, I think, a longer than usual session, but there were a lot of topics, so I couldn't help it. Right, so let's end the session here. If you have any doubts, please contact me, or you can contact the mentorship as well. And please go through some of these topics. Are extremely difficult topics, I understand. I've tried to simplify them down as much as possible, but I still understand that there are some issues. There are some of these topics which can be very technical in nature. So please go through them again. And if you have any doubts, you can always reach back to us. So let's end the session for now here. Thank you very much for being here. Good night.